On to topic 7 now. Again, this section is not included in your curriculum, but it's a bridge, again, to higher levels of algebra and some interesting things. Here we're looking at geometric applications using the Pythagorean theorem, two special triangles. I recall this from my high school geometry classes, and the distance and midpoint formula. Again, both things that you'll be using in pre-calculus. So using the Pythagorean theorem, there are many kinds of problems that involve powers and roots. Many also involve right triangles and the Pythagorean theorem. And what is it? Well, if we have a triangle, that is a right triangle, one of the angles is 90 degrees, then the sides adjacent to the right angle are called legs, and the side opposite are called the hypotenuse. The legs are usually referred by the letters A and B, and the hypotenuse by C. And basically the theorem states that if you square A and square B, that is equal to the square of C. And there it is right there. So if you have x squared and x squared equals n, then x equals the square root of n, or in some cases a negative square root of n. So how long is a guide wire if it reaches from the top of a 14-foot pole to a point on the ground 8 feet from the pole? Well, in something like this, I would strongly suggest you make a diagram. So we're wondering, what is the length of the hypotenuse? There's the 14-foot pole, and the guide line is 8 feet from there. So what formula will you use? Well, the Pythagorean theorem. So 8 squared plus 14 squared will equal d squared. And there it is right there. So 14 squared is 196. 8 squared is that, and that equals that. But we don't know what d is yet. Well, we have to take the square root of that. So the square root of 260 is approximately, put that in your calculator, 16.125 feet. Often they'll say they want you to round that to 3 decimal places, and that's what you have here. Okay, let's take a look at this one. This is a special case where both legs of a right triangle are the same size. We call this triangle an isosceles right triangle. That is, two sides are the same. So if you have A and A, let's work this one out. So that would be A squared plus A squared equals C squared. So we have 2A squared equals C squared. And then you take the square root of this and the square root of that, and that is C. And you can see we can take the square root of A squared out of there, and there's where we get our answer. Now this is sort of famous that if this side is 1, this side is 1, then you get 1 squared plus 1 squared is 2. So this squared plus this squared is 2 equals C squared. Take the square root of both sides, you get c equals the square root of 2. So if this side is 1, this side is 1, then the length of this side is the square root of 2. If you ever want to define what is the square root of 2, well, it would be if this side, if you have a rectangle whose sides are all 1, the diagonal of that rectangle is the square root of 2. And there's the proof of it. So here the hypotenuse of isosceles right triangle is 8 feet long. Find the length of the leg. Well, here we have 8 equals a the square root of 2, and we're going to divide both sides by the square root of 2. Now notice what we often do is we rationalize our denominator here, and we do so. Let me show you that. We had this in an earlier section. 8, the square root of, let me see, let's do this again here. 8, the square root of 2. We're going to multiply this by the square root of 2, the square root of 2. So that gives us 8, the square root of 2 over square root of 4, which is 2. These cancel out, and we get then 4, the square root of 2. So not too bad. Here they're not showing us a lot of the mechanics of it. Now this would be the exact answer. If you put that in and round it to 3 decimal places, it's approximately that. Now another one that's very, very famous for a right triangle is the 30, 60, 90 degree right triangle. And the measure is 12 inches. Find the length of the other side. All right, let's take a look at a picture here. Okay, let's study this a little bit. Again, they're not showing us a lot of what went on in the background, but here's a little bit. So, can you see that if this were an equilateral triangle, that all sides were equal, and then if we did an altitude that would cut the triangle in half, that this would be 60, this would be 60, this would be 60. That here is a 60, then this is a 90, this half of that would be 30. Now they're saying that this base here, the full base, or one of them is A. So A is actually 12. So in a sense, this side is A, this side is A, so this side is 2A, which is what they're showing here. So 2A equals 24, A equals 12, and that's what they're showing. So C is the hypotenuse here, that's 2A, and A is 12. Okay, so 2A is 24. This side is 24. This side is 12. Now this side, I'll show you if we go back to our A's here. So we're going to just deal with this side. So if we square this side, and we square this side, that's side A, that's side B, I'm sorry, that's side C, this is side B. Let's say we don't know what B is. So there's our hypotenuse that we're squaring. There's our leg down here, which is A squared. We're going to square this, get 4A squared minus A squared. That gives us a 3A squared. And that equals B squared, this side over here. Now we take the square root of that side, that's going to give us B. we take the square root of this side. That gives us the square root of a, or a squared is a, and then you're left with the square root of 3. So this is where we get this over here. And by the way, that's a given. If this side is a and this side is 2a, then this long altitude of our triangle is a, the square root of 3. So here they're saying if this is 12, we know this side is going to be 24. Well, what will this side be? Well, it's going to be, side B is going to be 12, the square root of 3. Because if A is 12, and we just proved that this side here is A, then it's 12, the square root of 3. This is that 30, 60, 90 right triangle. So, again, B equals A, the square root of 3, and we said A is 12. So, the hypotenuse is 24, the short leg is 12, and the longer leg is 12, the square root of 3, or approximately 2 3 decimal places this. Okay, so these are two special right triangles. This is if this side is 1, this side is 1, and this is the square root of 2. If this side is a and this side is a, this is going to be a, the square root of 2. If this side is a and the hypotenuse is 2a, then this longer leg is a, the square root of 3. And we just proved it. Okay, the distance formula. Now, when we have a coordinate plane, and we did a lot of these earlier, let me just show it to you here. If I can get some lines going here. Okay, I'm making a little graph here. Now this is going to be one point, let's say over here, and this is going to be another point over there. And now I'm going to make a right triangle. This will be my hypotenuse. This will be the right triangle right here. So if we have the coordinates of this point and the coordinates of this point, and we put them into this distance formula, there's my first point, there's my second point, we can actually figure out what these sides are. How many units is this? How many units is that? And using the distance formula, and there they're showing it to us in some detail, there is the distance formula. So we're going to take the x coordinates, subtract them and square them, y coordinates, subtract them and square them, add them together, and then take the square root of that. That is the distance formula. Now you're probably going to have to memorize this if you have to use it, but initially I'm sure they'll give it to you. So find the distance between these 2 points. Well, we're putting in the data into our formula, getting 2, getting a -7, squaring both, add them together. This is the exact distance of our hypotenuse. And there it is, approximated to 3 decimal places. Another famous formula that's used here, and I'll show you this one too. So again, we had the distance formula, but now we want to find the midpoint. What will be the coordinates of that point right there? We know this one and we know this one, but what's the midpoint? And that's this formula. And it's sort of an easy one. That is, we add both of our x coordinates and divide by 2. Both of our y coordinates and divide by 2. This is the midpoint formula that will give us that. And we want to find that. Again, it's just putting them into the formula. Adding together, this is 8 divided by 2 is 4. This is 5, negative 5 divided by 2. It's that. And that wraps this up.